Welcome to PreCal TRIG Fall 2021. This is a review for the Unit 4 test. If you've already taken the Unit 4 test and used all of your attempts, but would like to improve your grade, you need to go through this review with an example of each type of problem that you'll see on your test. Make corrections, and then let me know that you would like an additional attempt. You should be watching and taking notes, and then requesting a retake after you've corrected your test and studied. Now let's move forward to question number 1. Question number 1 asks, how can this logarithmic expression be rewritten? Think about where you want to start. What are the steps that we learned to answer this? Now, if you're stumbling on these types of questions and last minute trying to do your best, it doesn't take long to go back into the course content online and go through some of those practice problems. But taking notes will really help you be successful on these unit tests. So let's take a minute to break this down into something that we can work with. All right, we have a statement, and the question is going to be set up this way. We have a statement with log base 2 c times d to the 5th. Is what we're asking is that equal to 5 times log base 2 c plus 5 times log base 2 d. We want to know if that's true or false. Alright, so let's break that down. And if you look here, we're only raising d to the 5th power. So this is log base 2. If we pull this apart, multiplication with a logarithm can be broken into addition. But we can't put that 5 out in front because the 5 is only related to the variable d. So let me erase this and show you what they're trying to make sure that you look at this carefully. If that 5 had been written out here with the properties of logarithms, we could pull that 5 out here. And then when we're multiplying, this could be split apart into 5 times log base 2c plus 5 times log base 2d. Alright, but because the exponent 5 is only related to the variable d, we can't use that property. So this is false. Be very careful that you don't get tricked and look where that exponent is. Again, if it were outside and we're raising c and d to the power of 5, the properties of logs, we could pull that 5 out here. And then we can break this apart with the properties of logarithms into addition. But we don't have that. Alright, so we're going to go on and evaluate the next one, number 2. Okay, for the second one, we have 2/3 natural log A plus natural log B. The properties of logarithms, we can take that 2/3 and we can put it over here. Addition of logarithms, in this case we have the natural log of a and b, we can multiply the a and the b. It's just a different way to write it. So I'm going to start here, and I'm going to write natural log of a times b. And then I'm going to take that 2/3 that's in front, and I'm going to bring it here. It's going to become our exponent. Now what that means is we have the natural log of AB. This is what we're raising the power of A and B. So A squared, B squared, and the denominator is going to be the type of root. So we have a cube root of A squared, B squared. So let's go over here and see if that's what we have. Okay, in this case, they have the square root. Okay, now that is the opposite of what we have here. That denominator is telling us that we have a cube root, and then we're squaring A and B. So this is going to be false as well. Let's look at the last one. When we have subtraction, it's division. Okay. All right, so we have, and we're going to go ahead and, I'm kind of looking ahead at what my answer should be. We're going to go ahead and put this 5 here. So it would be natural log e to the 5th minus the natural log of f to the 4th. Okay, so subtraction is division, addition is multiplication. So we have the natural log of e to the 5th over f to the 4th. Now let me go and look and see if that's the answer. Check. Is that true or false? And in this case, it is true. Alright, so we have 3 things that we need to evaluate. Let's move on to question number 2. An invertible function is represented by the values in the table. So what we have is we have some x values here, and then when we plug that into our function, this is what our answer is, or our y value, or our f of x. So we're already told that it's invertible. So we want to match up the graph of this function. Don't be tempted to take and check each x and y value and look for positive 3, 6.4. Okay, what we need to do is we need to reverse that, so this becomes our y and this becomes our x. So this is what we're going to be looking for as our x, negative 6.4. So let me check each graph. Go back 6.4, and that's going to be approximately here, and then negative 2.6. Approximately, it could be here. Let's see, let's get something that's easier to visualize. Alright, remember we're starting here because we switched our x and our y to make it to get the inverse of this function. So we'll go to negative 2.6, it's a little over negative 2.5, and then up to positive 2. So it's not going to be this one. I'm not finding anything that matches. Let me move on to the next one, and let me erase some of this, and we'll go back and check our numbers. Alright, we'll start again. Remember, we're starting with this value, which was our y. Now it's become our x. Negative 6.4, it's almost 6.5, and then go up to 3. So this is a possibility. Let's keep checking. Negative 2.6, a little over 2.5, and then 2. This is looking promising. For the third pair, I start with negative 1.2, but I lost my focus and made a mistake and only went to 0.2. So I started checking the third graph. Alright, so let's go on to the third one. We'll come back to that in a minute. Negative 1.2 and 1. Hold on, let me see. Negative 1.2, I didn't go to the right place. Negative 1.2 is right here, and 1 is right here. So yes, this is the only one that would work. I just went to 0.2, not 1.2, and then up to 1. This one doesn't work either. So I only needed to check 3 of those to find 2 that didn't match and 1 that did match. You're looking for the inverse of that function, so you need to switch your x's and your y's. Let's go on to question number 3. We want to solve 5 square roots of 5 raised to the power of negative 2x plus 1 equals 1/5 times 125 raised to the x minus 2. Alright, let's take a deep breath and let that sink in. Look at it for a minute, and then we'll take that apart step by step. Alright, the first thing that we need to do is put these, let me think about this for a minute, find a common base. Alright, so I'm going to look at this, and it looks like our common base is 5. This is 5 to the first power times 5 to the 1/2. You would take, remember that denominator is going to be the type of root we have, so that would be a square root of 5 to the first power. Okay, and then we're raising all of that to this power. Take a minute and let that sink in, and write this down too. It kind of helps to have it written down. Alright, now let's keep going. Now, if you remember, in the previous problem, we can take that power and we can pull it over here. So we have negative 2x plus 1 times 5 to the first power times 5 to the 1/2. When you multiply numbers, we have the same base, you can add the exponents. So 1 plus 1/2 is 5 to the 1 1/2, or 1 times 2 is 2 plus 1, 5 to the 3/2. Okay, take a minute and let that sink in. So we have 5 to the 3/2 times negative 2x plus 1. Okay, let's look over here on the right hand side and let's see what we have. We have 1/5, so that's 5 to the negative 1 times 5. 5 times 5 is 25. And times 5 again is 125. So this is 5 to the third power to the x minus 2. When you raise a power to a power, you multiply those together. So this would be 5 to the first power times 5 to the 3x minus 6. When you have the same base and you're multiplying, now we're going to put these two together, you add the powers. So we're still working on that right side. That's going to be 5 to the 1 plus 3x minus 6. You can put together your constants. 1 plus negative 6 is negative 5. So this power is 5 to the 3x. Negative 6 plus positive 1 is negative 5. Alright, now let's look at the right hand side. We have the same base. We have base 5. And then look at the left hand side. We still have this over here. So we're going to take this and we're going to move it back over here. Negative 2x plus 1. And when we're raising a power to a power, we multiply those two things together. Okay, so we have 3 halves times 2x. So we multiply this 3 halves. Let me change my pen color. It's going to get a little confusing. When we multiply 3 halves times negative 2x, we get negative 3x. Let me go ahead and write this out. We're multiplying 3 halves, and I'm just taking that first number, negative 2x over 1. So this 2 cancels out, and we have 3 times negative x is negative 3x. So 5 to the negative 3x. We still have this 1 over 1, and we're multiplying by 3 halves. So 3 halves times 1 is 3 halves. Okay, so this is what the left hand side looks like, and this is what the right hand side looks like. Now we have that same base, so we can consider the exponents as being equal. Let me change my pen color one more time. Alright, so we set this equal to this, and then we solve for x. So negative 3x plus 3 halves is equal to 3x minus 5. I'm going to add this 3x to both sides just so that I can keep it positive. That's 0. And then I have 3 halves equals 6x minus 5. Add 5 to both sides. And then we get 6x equals, let me switch sides here. That's going to be 0 here, so we have 6x equals, I'm going to change this to 10 halves. Multiply 5 over 1 times 2 over 2, and we get 10 halves. 10 plus 3 is 13 halves. Okay, one more step. We're going to divide by 6 or multiply by 1/6. It's the same thing. And we get 13/12. X is equal to 13/12. Okay, but the key is to simplify. You can kind of take a look here and realize that the base is going to be base 5. So this is 5 to the first power times 5 to the 1/2 power. All of that raised to the negative 2x plus 1. So there's several little steps in there, and you need to remember what to do with your exponents. Once you have the same base on both sides, you can set those exponents equal to each other. You have an equation that you can solve for x. Let's go on to question number 4. We want to know which graph shows the function f of x equals negative natural log x plus 1. Alright, so let me get my pen, and we're going to evaluate that. Alright, y equals, let's just establish some things here. I may have a lot of work and run out of room, but let's talk this through. Y equals natural log of x means y equal log base e of x. So what that means is, if you remember what logarithms are, e to the x power equals y. So we can write that this way. E to the x power equals y. Now interchange your x and your y, so it becomes x equals e to the y. Alright, and that's what we'll be graphing. And then we simply, this is what we'll be graphing, simply find values for y and solve for x. So I'm going to set up a table here, and I'm going to choose some numbers that are pretty simple and easy. So remember, in this case, we're going to start with our y values. So I'm going to pick -1 and 0, I like 0, and +1 and +2. Alright, so our e to the y. Now I'm going to stop right here because I really don't have enough room to show you, and it gets very messy and very disorganized. But basically, if you go into Desmos and you look at the function of the parent function, the natural log of x, and then you apply these properties to it, then you can start to see what the shift is and what the answer is. It's going to be this second graph here. But there's a lot of explanation about how we get there. So use Desmos to help you with these graphing problems. That's totally fine. We haven't done a lot to practice this, and there's not a lot. I want to move on, not a lot of room to show the work. I want to move on to the next problem. For question number 5, we're asked, what is the value of the logarithmic expression? And in this question we have log base 3, 1 over 81. So I'm going to go ahead, let me go ahead and make sure that I've got my pen turned on, and I'm going to write equal x. So now let's apply what we know about logarithms and write this in a way that you can visualize what it is that we're trying to do. So what we're saying is we're saying 3, let's go in this circle pattern, 3 to the x is equal to 1 over 81. Okay, so now I think that you can start visualizing what's happening. We have a fraction here as our answer. So if we had, let's first of all look at it this way. If we had 3 to the x equals 81, what we're saying is 3 times 3 is 9, and times another 3, 9 times 3 is 27, and then times another 3, 27 times 3 is 81. So this x would be 3 to the 4th power is equal to 81. We can reason that out. Alright, but we have 1 over 81. So how do we get that 81 moved to the denominator of a fraction? We simply make this 4 negative. A negative exponent brings that down into the denominator of the fraction. Alright, so in this case, x is equal to -4. So there's a lot to really absorb in here. So take your time when you're answering these questions. For question number 6, we're asked, what is the equation of the asymptote in the graph of the exponential function f of x equal -7 to the x plus 2 minus 1? Alright, so let's take a minute to look at this. It's kind of hard for me to write this out, so make sure that you see that this is the exponent, and then -7 is the number that we start with, and then we're subtracting 1. Alright, now a function in the form of f of x, let me just write this out as notes or as reminders, in the form of f of x equals a times b to the x plus c. We have a function in this form. So this part right here is going to determine the formula for our asymptote, our horizontal asymptote. Alright, so all we have to do is identify what this is, and in our function it's minus 1, and then our horizontal asymptote is going to be y equal c. So we're going to take this number and we're going to plug it in. Y equal negative 1 is the equation of our line. That's our horizontal asymptote. For question number 7, we're asked what the solution is to the following equation. The natural log x minus the natural log 3x minus 2 equals natural log of 3. So the two inputs, this is a one-to-one function, meaning the two inputs have to be equal and positive. So let's set this up according to what we know. Alright, so we know that when we're subtracting logarithms or natural logarithms, then when we're subtracting, it's actually division. So we're going to rewrite this as ln of, let's look at what we have in that first one. We have x divided by, and in the second one we have 3x minus 2. Okay, and on the right we have ln 3, or natural log of 3, however you want to say that. Alright, now when we have it set up like this, we can pull this out and set up an equation and solve for x. So we're going to set this up as x over 3x minus 2 is equal to 3. And then simply solve for x. So let me change the color of my pen, and then we'll start working. Alright, I'm going to multiply both sides by 3x minus 2. We'll put that over 1 to make it easier to see, and then we'll multiply both sides by 3x minus 2. So you'll see here the 3x minus 2 cancel, so we don't have that denominator to deal with any longer. So on the left hand side we just have x equals, and on the right hand side distribute carefully. 3 times 3x is 9x, and then 3 times negative 2 is negative 6. Alright, the next step, what I'm going to do is I'm going to, it's really your choice. I'm going to go ahead and subtract 9x from both sides. Okay, so that gets rid of the 9x on this side. We're just left with negative 6. And then positive x plus a negative 9x is negative 8x. I think I did that right. Double check my arithmetic. Negative 9 plus positive 1 is negative 8x. Alright, the next step is to divide both sides by negative 8, or multiply by 1/8, negative 1/8. Those two negatives will cancel out, and you're just left with x on the left equals, don't forget to multiply this side by negative 1/8 or divide by negative 8, however you want to look at that. Two negatives make a positive, and we get 6/8. All we have to do is reduce that to divide the top and the bottom by 2, and we get 3/4. So x is equal to 3/4. Use your properties of logs to set this up and then pull this out. And then you have your equation that you can solve. Alright, moving on to question number 9, we're asked what is the inverse of f of x equals 4/3 x to the third plus 2. Alright, so we're going to There are a couple of ways to do this. Very straightforward. Look at what you're doing to x, and let's list those. Let me make sure I get my pen. All right, moving on to question number 9. We're asked, what is the inverse of f of x equals 4/3 x to the third plus 2? So we're going to list what we're doing. Okay, the first thing that I see that we're doing to x is we're raising it to the third power. All right, and then the second thing that we're doing is we're multiplying by 4. And then we're dividing by 3. And then we're adding 2. Now the inverse must perform the operations in reverse. So the inverse is going to, we'll start with number 4, is going to subtract 2. And go up to number 3, that's going to be our number 2. We're going to multiply by 3. Our third step is going to be to go to step number 2. Instead of multiplying by 4, we're going to divide by 4. And then our fourth step is going to be to take the cube root. Of your result. Alright, so intuitively we can do that. If it's not this straightforward, you can reverse. You can write it first this way. Y equal 4/3 x to the third plus 2, and then you can reverse your x and your y. So this would become x equals 4/3 y to the third plus 2, and then solve for y. There's another approach to this. Let's go ahead and use that approach, and you'll see that we're doing the same things. So we're going to take this where we've switched the x and the y to find the inverse, and then solve for y. So the first thing I'm going to do is I'm going to subtract 2. And notice that this is our first step over here. We'll subtract 2 from both sides. X minus 2 equals 4/3 y cubed. Okay? And then after we have this, we're going to multiply by 3. We could actually do this in one step. We could multiply by 3/4, which is the same thing as multiplying by 3 and dividing by 4 at the same time. Let's go ahead and take these two steps together. So we're going to multiply both sides by 3/4. And then that will cancel the 3/4 here, or the 4/3 here, and we're left with y to the third power equals 3/4. Let's go ahead and distribute that. 3/4 x minus 2/1 times 3/4. 2 goes into 4 2 times, and so this becomes 3/2. 3/4 x minus 3/2. Let me just go ahead and write this here so it's not as messy. 3/4 x minus 3/2 equals y to the third. And then our last step, you can see, to solve for y is to take the cube root of both sides. And then you're left with y equals the cube root of 3/4 x minus 3/2. Now it's written in this form. There may be something that you can, in your answers on your test, there may be something that you can take the cube root of, but I don't see anything here, so that's our answer. Question number 10 asks, what is the solution of the equation log base x 16/625 equal 4? So we're going to start with this problem by looking at this part of the equation, 16/625. And let's factor 16. Okay, so we're going to take 16. I know it's divisible by 2. 16 divided by 2 is 8. I'll keep dividing by 2 as long as I can. 2 goes into 8 4, and 2 goes into 4 2 times. So 16 is equal to 2 to the 1, 2, 3, 4th power. Now I'm going to factor 625. 625 is not divisible by 2. It's not divisible by 3. My trick for finding out quickly if a number is divisible by 3 is I add all the digits. 5, 6, 7. 7 plus 6 is 13, and 13 is not divisible by 3, so 625 is not. So I'm going to move up to the next prime number, which is next highest prime, which is 5. And then 5 does go into 625. And get my calculator out, do this quickly. 125 times. And I can keep dividing by 5 because it does end in a 5 or a 0. And 5 goes into 125 25 times. Keep dividing by 5. 5 goes into 25 5 more times. And that's as far as I can go. But you can see here you have 625 is 5 to the 4th power. So we'll rewrite this as log base x 2 to the 4th over 5 to the 4th is equal to 4. Take a minute and look at that. And let's interpret what that means. Use our circle pattern. X to the 4th power, we'll rewrite it this way. X to the 4th power is equal to 2 to the 4th over 5 to the 4th. You can write it this way. Keep simplifying. X to the 4th power is equal to 2 over 5 to the 4th power. You can pull this out here. Okay, so you can see that these two things are equal. X equals 2/5. And that's the solution to your equation. For question number 11, let's take a minute and look at this carefully because we have an expression. Let me get my pen. We have an expression here that we're comparing to 1, 2, 3, 4, 5, 6 different expressions to tell whether or not they're equivalent. So let's just analyze this for a minute and talk about what it is that we're looking at. Alright, so we have the natural log of 12, which we can express as the natural log of 3 times 4 over the natural log of 3. Okay. So if we take out this 3, then we're left with the natural log of 4. So right off the bat, we can evaluate that this is an equivalent expression. Alright, we know that when we're looking at logs, or natural logs, that division means subtraction. So let me go ahead and write it that way. This is going to be the natural log of 12 minus the natural log of 3. And right off the bat, I can find that expression here. So that's also another equivalent expression. Now the third expression that's equivalent is going to be, let me look here for a second, log base 3, 12. And again, that takes some time to pull this apart and talk about what a natural log is. We can write this as log of E12. This is just a shorter way to write. All a natural log is a logarithmic expression, so this is another way to write it. Minus log base E3. And then when we evaluate these, we can find this can be written as this. Now, these are the 3 that are equivalent. The other 3 I just kind of made up mixed numbers in there, and it doesn't make any sense at all. So I'm going to take those out. Those are the only 3 that are equivalent. Now let's go back in question number 12 and talk about what we learned in the very beginning, how to write the logarithmic form of the equation 3 to the x equals 21. So let me get my pen. Think about that for a minute. This is log base 3 of 21 equals x. Now let's go back and check that by using our circle rule. I don't know what really, I'm kind of making that up. This should interpret as 3 to the x power equals, keep going in a circle or circular fashion, 3 to the x equals 21, which is exactly what we have here. So this is the correct way to write this as a logarithm. Alright, thank you for watching. Thank you for coming. Again, I didn't really go into explanation about the graphing part, but use Desmos for your graphing. Think about what you've learned in Algebra 2, but don't get bogged down in that question. Use each of these to learn from your mistakes, and also if you see any mistakes that I've made, point them out so I can make those corrections. This is for assistance for you in your last unit test. Please make it count. Reach out to me if you need an additional attempt, but take your time on this. And I will be available every day this week, but after this week I don't know that I will be available for help. I think that you have access to tutor me in ClassLink through the remainder of the semester. So do your best and take screenshots. If you're sending me emails about questions, you need to be as detailed as possible or I won't be able to answer your question. Alright, good luck on your test, and let me know if you have any questions.